Yes.
All right,
Confirm you're seeing his slides.
Yeah, I can.
so people online should be seeing my slides now, and that's what you'll see for the rest of this until I'm done, in which case we'll shut this down. First, I'd like to say thank you. Thank you to those in the room. Thank you for those of you out in cyberspace. Whatever I'm able to say today is due to the work of others and not to me. And if people didn't go, we're going to be talking about over 1,000 sites. I and my team couldn't hit 1,000 sites. And eventually those data will affect how other people view their streams and how other people view their salt problems. So thank you. That's the most important thing here. Today, I'm going to talk about surface and groundwater contamination, late summer and early fall. That's why we set this up. This is Winter Salt Week run in October. Long after we've done any salting. The science told me we had a lot of salt out there. I just wanted to see it for myself across the landscape and make this information available to other people. So you're going to see a lot of data that's not ours. It's due to other coworkers, but it's also due to the partners and the volunteers. I'm going to do some basic background in and out today because we have so many people that are new to this topic, except for the experts, those two. So salt is so confusing for everybody because there's so many different ways of referring to it. You have salinity if you're an oceanographer. Total dissolved solids, you have that as a drinking water issue. Electrical conductivity or specific conductance, we use that in limnology or aquatic ecology. Measurements of salt, this is literally cooking as another way. And then chloride is a relatively new way of measuring it, especially for volunteers. And the reason why is we have some new tools that 10 years ago weren't available. Also, when we talk about salt, the key to the salt is the fact that you have this compound that breaks apart. So it's a solid, and then you add it to water, and it disassociates. So the sodium chloride disassociates to sodium and chloride. You have a cation, a positively charged particle, and an anion, a negatively charged particle. This occurs naturally. Most common in fresh water is going to be a calcium magnesium carbonate, something tied to a soluble rock like limestone or dolomite. This is what it looks like in practice, where you go from the solid rock salt or table salt. So you have your sodium in gray and your chloride in green. It hits the water. Here's your little bipolar solvent, fresh water, the universal solvent. That polarity pulls this thing apart, and you end up with these ions surrounded by water molecules. And that's the secret to why salts disappear, but it's also the secret to how we can measure. So it's all about the solubility of the salt. If you've got a soluble bedrock, you have a lot of dissolved ions and hard water that's draining through limestone. Whereas if you were draining through volcanic rock, like the green areas here, those would be less soluble. You would end up with soft water. It's all about geology. Your background water chemistry in terms of hardness and softness initially is all about geology. And it's not simple. It's really hard to generalize. This is a geological map of the United States, underlying geology, but it laid on top of it precipitation, because remember, concentration also depends on how much water you have available. So same amount of salt, but little water ends up higher concentrations. The blue area here are basically your soluble rocks, primarily your limestone, dolomite types of things. Here's PA here. Take that, turn it into conductivity. This is United States conductivity. Blues are going to be low. Reds are going to be high. In other words, lots of dissolved salts. So if you think we live in a salty world, you haven't gotten to the Midwest. It's a whole bunch of old ocean beds and stuff. Lots of solubility naturally. But you see how complicated. You see all these stripes in here. It's our geology looks like an accordion. It's just all sorts of stuff in the east, with the Appalachians crammed together. So here's Pennsylvania's just folded carbonates. And some thin flat layers out west. We're down here in Chester County in the southeast. The Delaware is in here. Your background salts just depend on where you're at. And in many cases, our watersheds cross in and out of these soluble rocks. And that makes it really complicated. This strip is soft, this tributary is hard. All right, we're stuck.
Sorry.
Yeah. Still stuck. Hold it. Got dead battery. No, we don't.
There you go, raise the speed.
There. So this is that same United States map. They just took underlying geology, converted it to connectivity, and you can see the stripes, little bits of elevated local limestone streams. For us, the best known is going to be Valley Creek up in Chester County, Valley Forge, PA. This is another, just Chester County shows you the complex geology. It depends on where you're at as to whether you have these carbonates shown in gray. If you're in it, you tend to have higher conductivities, but the highest, notice these black dots, they occur all over the place, sometimes in this color, sometimes in this color, sometimes in these mixed zones. So it's really hard to generalize background ions. Here's another way. These are based on conductivity meters. This is all from the Delaware. I plotted 3 of these. Actually, Dave did this for me. This is White Clay Creek here at Stroud Center, limestone influence. Aquashola is up where the Poconos punches in Berks County. This is Nolde State Forest. And then we have a Pocono stream down here, super low, and we have Valley Creek, super high. All in our area. These are all streams that you can get to in an hour or 2. All different because of geology, primarily. So differences are natural, they can be ecologically important. You don't think about background salt being important, but if you remember from high school, you might have done this simple little test, a little poke of the finger, put blood on a slide, and then add either deionized water or salt water. If you add deionized water, you blow the cells up. These are red blood cells, and they just go. And if you added salt water, you shrink them all. All you're doing with salt water is taking all the water out. With the fresh water or deionized water, you're just pushing water into the cell. So under the best of conditions, the water in and the water out is unequal. That's how you stay healthy. You get dehydrated, you get into a situation where you don't have enough water and your cells are struggling. That's an osmoregulation thing. All living animals, freshwater, marine, terrestrial, they're all fighting this salt balance, water and salt. When we mess it up, you blow up or you shrivel up. So this road salt question, we're focused over here, but it's actually a pretty big area of the United States, and it's also a Canadian problem. It's also a European problem. And in other parts of the world, there's salt problems. They're not road salt, though. They're primarily industrial or agricultural. But it's a salinity problem, more salt than we wanted. This is the salt belt goes from Virginia to Maine and over to the Dakotas. We're all hot on this topic now. The funny thing is, we've drawn attention to it, but way back when, the real smart minds in the United States recognized this as a big problem coming our way, and they tried to warn us. 1970, a report of the National Academy of Science and the National Academy of Engineering published a report, 1970, 2 years before the Clean Water Act, reviewing what we know about de-icing salts on water quality and the biota in water. That single report and attention to this idea there are big piles of salt suddenly appearing in communities and winter treatments going on the land, totally unregulated. it didn't miss people's attention. Here's just a subset of papers drawing, and I just highlighted two things. In red is the year. That first report, 70, 71, 72, 72, 72, 76, 77, spanning things from de-icing salts on water quality, runoff, de-icing, water pollution, street salting, groundwater contamination, road salt, effects of road salt in Vermont, effects of de-icing salt, effect of road salt. They were all over this almost 50 years ago. They're doing all this study, and you and I never heard a thing about it. We had the blinders on. We were hearing about lots of things. This is a great graph I found. It's developed by a groundwater company. It shows all sorts of different kinds of pollution. You have the ag over here, nutrients and pesticides. You have septic going on over here. You have residential and industrial. You have your drinking water supply. And then you have the groundwater, because this was a groundwater company. And you notice how all these pollutants end up in the groundwater. And what's neat is they actually have road salt in this thing. They red flagged road salt has a picture of where the pollution's coming from. There's pipes, there's groundwater, there's runoff overland flow. So road salt gets to the stream by way of stormwater in the pipes runoff, by way of wastewater, because remember what we're drinking ends up down in the wastewater treatment plant, as well as we live salty lives, and then in groundwater. And these guys drew attention to it. I got started in this, looking at urbanization way back in the 90s, but my best guess is about 1999. I said, I got to pay more attention to chlorides and road salt, separated from just conductivity. But then EPA hired us to look at mountaintop mining. That's carbonate salt. When they take off the mountaintop and fill the valley, all of this young rock ends up dissolving carbonates. And then in 2012, the RBC brought us in to look at produced water. Marcellus Shale is old ocean bed. So when they frack it, it comes out salty, high salt, sodium chloride, as well as carbonates. Really, really salty. When I said urbanization, these are the data that red flagged for me somewhere in the 90s. This is a study we're doing on a school field. This is 157 sites. These are bug scores. So these are all the bugs summarized in a score. 20 is a great string, 0 is a stinker. And then you have everything in between. And I lined them all up. And I plotted them against conductivity, dissolved salt. The more salt was in the system, the more degraded the system. That's when I added chloride. As soon as I realized that I needed to understand, I already had alkalinity carbonates. I needed to see what was going on with road salt. When no one, at that point, no one was talking to me about it. Well, we've seen this pattern, not just in the Schuylkill, but also in the New York drinking water watersheds, also in the Delaware River Watershed Initiative. This pattern shows up everywhere. You got a lot of sites in the salt zones. But the thing is, this is correlation is not always causation. You don't know what's going on. But the funny thing is it's showing up everywhere. That same Schuylkill site, there were 19 sites we sampled repeatedly between 96 and 2010. 15 of the 19 increased significantly, statistically, and this is one grab sample in June. We're not sampling in the winter. But look at them, the only ones that didn't go up were up in the mining areas in Maine, a very agricultural stream, not many people. This is what it looks like you drill down on that range. Wissahickon, very urbanized, Manatawny, kind of suburban, and then the North Kill is really quite rural. Notice you get more salt as you go, because the Wissahickon by 1996 was dealing with 20 to 30 years of road salt use. But the bottom line is the pattern is there. It's just the degree of change has to do with where you're at and how much road salt will be used. This shows up really well here. This is all the road salt that's been used in the United States since 1940s. we're right now around here, 55 billion pounds per year. That's 12 times what we used pre-1960 and twice what was used in 1990. So we're using a lot of salt. These are 3 streams in our area that have long-term data. It's really helpful. The red stream is Valley Creek. The blue stream is the Brandywine at Chad's Ford. And the black dots here, that's White Clay Creek out here, where we have Newark Road, we have 926. And we're in West Marlboro Township and prefer to put down grit than road salt. So we haven't changed much. We're down here 10, 12 milligrams per liter chloride, whereas you've got a 30-fold increase over the same time period in Valley Creek, a much more urbanized watershed. The thing to look at though is remember, go back here when they weren't salting very much. Clean Water Act 1972, where we have data from the 40s or into the early 60s or late 60s, we're down here 5, 10, that was background, and we were still there in our earliest data. That's why some of our data in Chester County are so valuable, is because it goes back so far. Here's where it looks like in terms of development, Valley Creek is almost 60% developed, whereas the Brandywine's only 30%, whereas White Clay at the Stroud Center is only 70%. The first study that pointed out we had an increasing salt problem in our area was actually data out of the Schuylkill, published by a grad student at Drexel and Chris Crockett, who worked for Philly Water at that time. And they took an old data set, 1973 to 1999, and just looked at trends. And you saw good things like ammonia and other nutrients, phosphorus going down, but sodium and chloride both doubled during the time frame of this study, 73 to 99. 2 years later, Pauly repeated that using drinking water supply of Baltimore, White Mountains of New Hampshire, the Hudson River Valley, a bunch of other sites, and found it repeatedly in other places. Got published in a very prominent journal, the Proceedings of the National Academy. This paper, 2005, after 30 years of people knowing that road salt was going to be a problem, this was the one that rang the bell and started getting people's attention. So we have this snapshot. We're like 20 years after that. Why are we doing this? We want to know, I want to know, I think as a management tool, we need to know how much road salt is in our streams months after it was applied. October. By going to October and by focusing on base flow, we're asking a question about groundwater contamination across a wide geography. Everyone takes a water sample, they think that's the stream that's now. They don't think about how much water is underground. So let's go through a couple of things because I know people don't always know. Base flow, what do I mean by base flow? Well, this dark black line here, this at the top, that's stream flow. And so you have your floods and then you drift right back down. That red line is base flow. That's just what's in the stream if it wasn't overland flow, flooding type of thing. And then your groundwater is down here. Well, we're targeting this period, say at the end of the summer, early fall, where there's little rain and most of the water in the stream is groundwater. It's not tied to any recent rain event. It's tied to rain that occurred quite some time ago. So what is groundwater? Well, groundwater is basically the water below the water table. And sometimes it's shallow, it's up here, it's unconfined. In other words, it has rapid exchange with rain, precipitation every year. Some of it's deeper, confined, sealed off by beds of more impervious rocks. And in some cases, you go deep enough, you end up with brines. You end up with water that's been down there hundreds of thousands or more years. That's the neat thing about this image is it shows you pathways to the stream. In other words, it rains, the water recharges, goes into the ground, filters through the ground, hits the groundwater. If you want to think about groundwater, if you've ever dug anywhere around near a stream, it doesn't take very far. Go down a foot or two, and usually you hit water. That's the groundwater. You're hitting that permanent layer right here. Some of it's young water, some of it's years old, some of it can be even older, depending on the distance away. You know, it has to travel to the stream. It's basically filling up pore spaces and fractures in the soil and in the bedrock. It's all tied to the water cycle. Basically, this road salt problem is riding on the back of our water cycle. So this is Pennsylvania's hydrologic cycle. On average, we get 41 inches of rain, falls to the ground. A little over half of that evaporates up through transpiration through the plants or just normal evaporation. So half of it's lost back to the atmosphere. Of the half that's not lost, 7 inches flows off. That's your stormwater running off the land. That's what gets collected in the stormwater pipes or the overland flow. But about 32% goes into the ground and recharges the groundwater. And the funny thing is that same amount flows out to the stream. So of your 41 inches, about 20 inches comes out in the stream. It's just some of it happens rapidly during the storm, but more of it actually comes in. So 64% of the water in a stream over a year is groundwater. Most of the time when you're looking at a stream, you're looking at groundwater. So that was the other thing we targeted. We told everybody, don't sample if it has rained in the last several days. We wanted a non-rain sample. So when you're looking at what's in the stream, if you're sampling in the winter, you've got both pathways. But if you're sampling in the summer when it hasn't rained, you're looking at road salt that's following this pathway through the groundwater. And that's what we wanted to see. So instead of that stormwater, wastewater, groundwater, when we're sampling in October and it hasn't rained, most of what we're sampling is groundwater. And since most of our streams are tiny, little headwater streams, there's no wastewater treatment plants. What we're really looking at, in almost all of our sites, is groundwater contamination. So where's all the salt coming from? This is a statewide budget published for New Hampshire. Parking lots, half municipal and private roads, another 30%. So 80% is local, but it all depends on the site, whether it's going to be parking lots or roads or some combination. It could be 100% of one or 100% of the other, depending on the size of the watershed. There aren't a lot of good data on this, but here's another one I just found in the last few days. This is for the Chicago area, so it's a big area. Again, 70%, 72% is private or is local. It's either private or municipal, but it's kind of flip-flopped. In this case, the municipal applications accounted for half, as opposed to parking lots. I'm not sure why it's that different. Is it just the geography? But again, it all depends on the site. This is the area that they were quantifying. This shows you your total salt load. The orange here is road salt. The green here is wastewater treatment plants. What you can't see, so total amount of salt coming through wastewater treatment plants for the Chicago area, it's not dominant, but it's significant. But you have to be where the pipe is. And that's generally downstream. That's generally in these high concentration areas. And most of your sites are not going to have it. This rural area, notice the yellow here is agriculture. Agriculture can be salty, but not like road salt because we're applying it by the dump truck load. So who should we be talking to? Our approach for the last several years has been talking to people like you. Because road salt's a local issue. We asked for it, we paid for it. We're addicted to what conditions it creates for winter. So when talking to locally, you're talking to the owners, the voters, the taxpayers, the planners, protectors, the fixers. That's how this is gonna be fixed in the long term. And that includes a whole lot of partner organizations, far more than I can list at the bottom. Because they give the foundational connection to a bunch of individuals that are invested. And we have some tools that weren't always here. As a student, I could use a conductivity meter, but we never had these chloride strips. These chloride strips are just a game changer in terms of sending people out. But many of you have done that. But at Stroud Center, we want to make sure that data are clean. So we do 2 measures of salt. That's our quality assurance. We're looking for errors. Everybody makes mistakes. The question is, can you catch them so that you don't end up talking about it? Last thing I want to do is talk a lot about a data point that's actually an error. So we do 2 measurements, specific conductance, which is all salts, and chloride. And the reason why is they relate really well. If you have nothing else going on, if you just dissolve table salt into deionized water and measure the conductivity, this is the line you get. It's just perfect. Add salt, increase your conductivity. Well, this is what it looks like in the real world. These are data out of the Delaware watershed versus that little beaker on the desktop. You notice how similar they are. And the field data are noisy, especially on the low end. That's where your geology comes into play. But once you're getting conductivities in the 800 to 1,000 or 3,000 or 10,000 or 40,000, it's all about road salt. Remember what we said, it's about the dissolving of things. And the conductivity changes because you go from this to this. And then you run a pulse of electricity through it. So you have a negative and a positive, and your negative, in this case chloride, and your positive, in this case hydrogen, but it could easily be sodium, migrate, and it generates these ions moving, move the electrons, and that's how you get the electricity, and that's what we measure with the conductivity meter. Or you could hook up a light bulb, and if the energy is flowing, the light goes on. So you set up an experiment. You could do this with your grandkids. You go in, deionize your distilled water, put your probes in, no bulb on it. Deionized water will not conduct electricity. No ions to help that electricity move through the water. You can put a jar of salt there, stick the probes in, no light on. There's no movement because there's no water to cause the salt to separate into ions. And those charged particles are what allow the electricity to flow. So you add sodium chloride or whatever to the, and suddenly you have charged particles, you have electricity or electrons hitching a ride with those particles. You connect the electrodes in essence, you connect the charge, the light bulb goes on. This process of dissolving things happens all the time. It's just road salt interferes with it. So rain falls on the land, and that which flows quickly to the river, either through your stormwater system or just over the land, has a short residence time, has very little time to pick up salt, low conductivity. Rainwater is super low, and surface runoff is super low too. However, it goes into the ground, longer residence time, picks up more salt, higher conductivity, higher salt. What we do with road salt is we load up salt in both directions. This way, to spike during the winter. This way, the groundwater contamination that we're measuring in October. So we're lucky enough, and we have Jack in the back here who helps run these things down in First State. This was one of our earliest sensors we put in. This is Rocky Run down by the Concord Mall, part of First State National Historic Park. This is every day for the last 5 years. Winter spikes. Summer baseball, 2 things. Winter, notice how high. And this was the first time I got knocked between the eyes. Conductivity went up over 45,000. That's near seawater in this little freshwater stream. But you also notice there's a whole bunch of noise at the bottom. These are the flat base flow areas, but it's not always flat. It's just compared to those spikes, the noise disappears. So this is drilling down. The orange up here is your conductivity. This is the water in the stream. These are little storm events. That's the fresh water, the rainwater coming to the stream, and you notice what it does, conductivity drops. It dilutes the salt. And then it comes back up, and then another little storm, it dilutes it a little bit. So if you look at enough of that noisy little flat area, it looks like this. And it's a real problem when you want a simple number, because it's all over the board. But the truth is this is your best guess of what groundwater looks like. So we started sampling, doing snapshots 3 years ago. We were lucky, good partners. Around Westchester, the Valley Forge TU, and our friends at TTF in North Philly and Montgomery County went out and did something that no one was doing. We wanted a data-dense sampling event. Because remember, everything about road salt is local, local, local. If you have one data point, people are just gonna say, well, that's too bad. I'm over here. That can't be my problem. We did this high density in part because the Westchester area, there's 7 municipalities that are involved in that conversation. You have to be able to talk to all of them, which means making the data relevant. The other thing is you're going to have high spots and low spots. Those high spots are where you should focus your attention. That's where those salt is coming in. And the low spots, you put those up as an example of this is what it could be. We did those, they were great. I learned a lot just by doing those first ones. But then last year, or earlier this year, actually, at this point, they had their first winter salt week. This is organized by Wisconsin Saltwise, had a whole bunch of states, had a whole bunch of programming, and I'll come back to this because there's another one happening. But we piggybacked on this, the local action day, salt monitoring, and said, let's see if we can take these little snapshots and blow them up and make it a regional conversation. Let's just invite anybody who wants to say yes. So we did really well. We got 600 sampling points. I've never gotten 600 sampling points on one day in my life, much less covered this kind of geography. Now, we were targeting people who live in urbanized areas because that's where road salt is primarily a problem, unless you're below the local salt mound. One of those can ruin all your neighborhood, and it's only one. So we did it again, but instead of being in January, we went to October. And what did we learn? Well, first of all, we got even more participation. It caught fire. Instead of 600, we're almost at 1,200. We saw almost a 90% increase, and we're not done counting. So I apologize. Now we're getting into the incomplete part of the story. But if you look at it, our goal was to push west and to push north, away from our stronghold, which is really southeastern PA, New Jersey, easing up into the Poconos. Well, we grew all over the place in terms of participation, including up in the northwest, up by Erie. Well, anybody who's been up there in the winter knows that they got a winter problem. And we're really interested in getting more data up there where the lake effect just pounds them and pounds them and pounds them. My goal here is to understand how road salt treatments or your approach to managing road safety may vary geographically across these basins. It probably will, but we won't know unless we ask a question like this. So when we look at this, we had 75 groups, we had over 700 participants as far as we can tell. We had hotspots, 62 of them. We had another almost 250 of what I call medium high, still a bucket load of salt. And you notice they're always surrounding those hot spots. So you're dealing with gradients. And then if you just go to the medium areas, you pick up even more. Always overlapping, but now we're leaking into the rural areas that maybe are not super high density, maybe you're not salting like crazy, So they're not gonna be the red dots, they're gonna be orange or they're gonna be yellow, they haven't gotten to the red category yet. So I took all those data and this is just a graph of all those sites from highest to lowest. 1,034 sites, 1,134 sites, so not all of the data yet. And I plotted in 3 regulatory or recommended concentrations. The oldest one is from EPA 1988. The feds have not updated their salt criteria since 1988 because it's complicated. They have, it's not for lack of trying, but every time they get to a point, more data comes in and they realize that this wouldn't probably be protective, and then they start the process over. The Canadians did this now almost 15 years ago. In 2011, they came up with 120. That was a concentration. Above that, and salt's going to be impacting aquatic life as we know it. More recently, in the last 5 years or so, Maryland and Ohio have defined salt as a stressor if it goes above 50 milligrams per liter. It may not be the only stressor, but both of them are operating with that level to say that, okay, if you have this in the stream, you have salt adding stress to an impaired waterway, therefore you have to start regulating the amount of salt that reaches that stream. So 3 different layers. Only 5% of our sites hit the EPA standard. Now remember, the trick on that one though is that was supposed to happen once for 4 days or less, so it's a 4-day average, occurring once every 3 years. This is all summer long, all fall long, every year. So how does it correspond? I'm not sure. The Canadians, we added another 22% of our sites, 247. To hit the Maryland and Ohio, we add another 388 sites. So you total them all together, 61% of our sites have qualified or would be classified to exceed 1 or more of the 3 salt standards that I commonly work with talk about. We have a salt problem, not all the sites, but a whole bunch of sites. And there's a whole bunch of sites that are elevated, but not exceeding the 50 milligrams per liter, at least not in this sampling. We cut off here because that's where the strip cuts off. We may do better on that later. How does it compare to January? Well, I just plotted January here, and I took the data you're just looking at here. First thing I did is I had to take our new data and shrink it down because it peaks at 1,000 microsiemens per centimeter or milligrams per liter, whereas in January, we needed to go to 10,000. We had numbers over 6,000. January was complicated. It was a little stormy. It was icy, depending on where you were in the Commonwealth or where you were in the region. There was icing, de-icing going on, and we picked it up. So we didn't hit the super high numbers. I'm not surprised. Salt hasn't been applied in months and months. The middle categories, percentage-wise, are about the same. And the ones, instead of being high, ended up more often just dropping down. So we kind of dropped down. I expected that. Now, eventually I'll be able to put these 2 data sets together, and where we have data from both, I can tell you exactly how it looked. But in January, I took the January data and plotted it against some of our earlier data. This from the Westchester area, and this from the Tacony, Frankfurt area. The new data is plotted here, the old data plotted at the bottom. If you're above the line, it means the new data, the January data were above the base flow data. We saw that a lot in the TTF area, so they were salty on that day or recently. Whereas in the Westchester area, we had a bunch that lined up and some that didn't. So remember 7 municipalities in Westchester area? Some of those municipalities were salty. Others had not. When we were running our salt event, we saw rain, but we know based on conversations that people were seeing salt trucks out. This will be very interesting from my perspective because this will, instead of being based on a limited number of sites, will be a bunch of geographies, and I'm curious to see how that looks. The other thing is I took this, and this is because I knew Pete would be here, this is just to poke a finger in the eye of Valley Creek. And anybody who wants to pretend like they understand their data, stay in your lane when you're dealing with one stream versus another. I plotted Westchester sites versus Valley. Valley is very, very limey. And this is one of the reasons why it's so challenging to generalize. This is chloride, this is specific conductance. These are all the data that we just collected. There's on average 155 microsiemens difference. This is basically elevated conductivity due to limestone. Still has a road salt problem. This is a road salt curve. But the neat thing about Valley, it helps me remind other people, just pay attention to your watershed or be careful when you're combining among watersheds, because there's underlying geology that is also embedded in that signal. And this is a great example. And I love the fact that Valley Forge 2 just keeps giving us data because it's this limestone endpoint. All over the Commonwealth, there's just slivers of limestone affecting things. And Dave was dealing with somebody recently last week, Dave Ressler, and we had to go online to figure out, oh yeah, they have limestone in that watershed because the data didn't make sense. It was the conductivity and the chlorides didn't shake hands with a bunch of other sites. It was all a matter of where the sites were. This is data not from us, but from a new study that I really like because it helps people understand what we're dealing with. This is from that Chicago area study. This goes from 1960 to 2021. These are all wells. They have a lot of data points, 4,000, 2,500, and they're different depths. So these are wells that are 90 feet or less. These are 60 or 30 to 60 meters deep, so 90 to 180 feet deep, and then up to 300 feet deep. So shallow, medium, super deep. This is all year round. You'll notice from the 60s to now, increasing salt, just like you would see in the streams. The groundwater has been tracking what you see in the streams. Same thing for the shallow, same thing for the medium deep. Then let's go to the summer. So there's no contamination of recent salting events. The shallow wells show no trend. So down to 90 feet, that shallow groundwater, which it's hard to think of 90 feet as being shallow, but when you're going down to 300, it is. It's all young water. It's basically seasonally flushing itself. So when we're measuring the salt in the stream, it's in part diluted by this fresh water in the shallow wells or shallow groundwater. Whereas when you go to the deeper wells, this is in the summer, you see this gradual increase over time. We're contaminating the deep groundwater, and the groundwater we're measuring in October isn't coming out of our shallow groundwater as much as it's coming out of the deeper groundwater. What does that mean? That means it's going to take a long time. Why did we get here? Safety, economics, people's expectations. Road salt in the 90s became a political issue. It was complicated, but road salt applications were a thumbs up from a number of different directions. But what it talked about was aquatic life or infrastructure or drinking water quality. Well, that's starting to change. It's starting to rebalance. We know we can do better. There are ways of calibrating your application using better plows, using salt and brine. There are great examples from Maryland, New York, Wisconsin, Minnesota. They managed to decrease their road salt use by 30 to 50%, depending on the location, depending on the motives. You can go online and see accounts of that. I want to show you one. Again, this is down from First State. This is where the Stream Steward Center is down here on Rocky Run. So here's 202. Here's the Concord Mall. Here's the Sears that closed. If you've been down there, it's just a desert. This is what the parking lot looks like. No customers. We assume it's not salting. Remember, I showed you this, the Sears closed in 2020. And we had these mild years and we're like, is what's going on here just about closing the mall, or is it about the mild winter, or is it, and we're just starting to think about it. And unfortunately, many of our data sets don't go back this far. And you notice that first winter was nothing special either. But what we did is we took the flat periods in here and played with them. So this is summer at the sensor on Rocky Run, below the Sears, below the Concord Mall, below all of that other development, that 60% developed watershed. First 2 years were high, and then we dropped about 100 microsiemens. The conductivity dropped, but it hasn't been declining. Remember what I said, that late summer water, that's not shallow, that's deeper. And that's going to take a long time. So five years with mild winters and a chunk of that parking lot being taken offline in terms of being really salted, we're not seeing anything. And I'm not surprised. We've seen this in the ag setting. Changing fertilizer doesn't show up in the stream for years. Could be 10, could be 20, might be more. So talking points for all of you, and this is for the people online. We use a lot of road salt. I like this number, 55 billion pounds a year. It's twice what we used in 1990, 12 times what we used pre-1960. Second thing, road salt contaminates our drinking water, our groundwater and stream water, and it damages our infrastructure. It's hitting us from 3 different directions. The concentrations are always elevated. The spikes can approach seawater during a storm. They say $100 in road salt, which is about 1 ton, causes about at least $3,000 in infrastructure damage. We're paying for road salt use. But just like every other infrastructure challenge we have, kind of have the blinders on. We're accelerating the aging. So we build a bridge, it should last 75 years, maybe it only lasts 35 years. Somebody's going to be paying for this. The salinization is only going to get worse unless we use less salt. This is not biologically active. The communities have reduced their salt by up to 50%. It's not going to stop it. We're not going to stop using road salt. We just have to slow down the increase. Our sampling, this sampling event, we sampled groundwater months after salt was used. 61% of the sites exceeded at least 1 standard. The contamination is not going to clean up overnight. The shallow groundwater always flushes. It's the deeper groundwater that we're replacing fresh water with salt water. And it's accumulated and it's down deep. And that means it's going to take time because the deeper it is, the older it is. And that means the replacement time is longer. So the solutions are not going to come from one direction. They're going to come from multiple directions because that's what got us here. It's going to involve the state and the feds. It's going to involve the private people. It's going to involve the municipal people. There's a group, if you want to go and get involved more, you can scan this QR code or you can just Google the PA Road Salt Action Working Group. It's a group of people. They're growing in size. They're involved in all sorts of different things. 70 members now, monthly meetings. Talking to landowners, talking to state people, talking to municipalities, providing literature, lots of information. Mary Rooney is one of the leaders. You can contact her. Last day, we'll be doing this again. Because remember, there's a picture of the salt in the stream from the winter, and there's a picture of the salt in the stream in the late summer and fall. So Winter Salt Week will happen. Again, it's in January. We'll be sampling on the 30th, but they'll have these webinars. All you have to do, it's free, you sign up, and once a day at noon, they have a webinar that will have somebody sharing their experience with the problem or with how they're approaching the solutions. So that's my last slide. And with that, we should take the slides off, and I will stay as long as you want to ask it to me. do my best to answer questions.
John,
Yeah.
can you take questions? If there's any questions in the room, just repeat the question into your,
Okay,
so that the folks online can hear it.
if I don't, remind me.
I will.
So, questions in the back?
Yes, you mentioned that West Marlboro is using grit, and I was wondering if you could explain that, and if you could speak to any local municipalities that have reduced their adult use.
Well, that's the only one, I can't say they reduced it, and I'm not sure anybody has really reduced it around here. Oh, I'm sorry, repeat the question. Explain grit, and do I have any examples of local municipalities that have done well? And I don't have for the last question. Grit is all about traction, same as snow tires, same as studs, same as chains. So it's just about increasing your traction as opposed to trying to get rid of the snow and ice immediately. It's an old thing. We used to use sand. They used to use cinders. Fortunately, they don't do that anymore. So grit quite often around here, I think, is ground up shale. So it's just about increasing traction and letting Mother Nature, the sun, do more of the melting than road salt. And the tires grind it up and then the plow takes it away too. Yeah, Brian.
John, it might be worth noting, at our, CWMP had a road salt workshop for municipalities on how to reduce salt use, and the city of Newark might be one to look at. We're thinking about having them speak when you speak to the Christina Basic Task Force. It seems like they've been working for a couple of years on salt reduction, pretty proactive. So they might be a good example to look at.
I've been relying on Jeff to tell me what goes on in Delaware, and most of what I've heard so far. Now, Newark is closer to Maryland. Maryland DOT has cut the road salt use in half by brining through the storm. I haven't seen any municipality doing that, but better calibration, better plows can go a long way to making, a 30% drop in your road salt use. So I'll talk to the Newark guys and find out, but what Jeff told me out of Wilmington was primarily more what we would call anti-icing. In other words, pre-treatment with brine. That's not actually less road salt. That's just a different form of road salt. Whereas Maryland DOT reduced their road salt use by, it's only 10% of the amount of salt that they apply. They brine through the blizzard because brine is 32% salt as opposed to 100%. It goes down, it's a micron thick. An hour later, the plow comes by and it doesn't remove it because it's down there on the asphalt, and then they layer on more brine. I think that's part of the solution for around here, and Maryland has much the same weather as we do around here. So I think that there's some solutions there. But I'm hoping anybody, we're looking for examples. Yes.
That's what I was gonna ask about brine versus the rock salt. I'm in our township in East Goshen, that's brine.
Yeah,
I don't know if they do it through the storm or I know they do it for free.
everybody does pre nowadays.
But so that's, I'm saying that it doesn't difference. So it will have the same impact to the watershed then.
They basically, from my perspective, they just added brine salt on top of the rock salt. It allows the plow to be more effective and therefore the road gets clearer. But guess what? Maryland did it with brine and no rock salt. Their roads are not, they're using half the salt and the roads are clear earlier. So most of what I see, and Westchester brines, everybody brines, Copson brines, it's a pre-treatment that prevents snow and ice from adhering, from freeze-sealing to the asphalt so the blade can't remove it. So that was the question. This brining that goes on, is that helping reduce road salt? The data would say no. They've been brining for 20 years around here, doing pre-storm brine treatments. It has helped plow efficiency. I think all it did was change the expectation. We need, with the same amount of road salt, you basically have a clear road earlier. If they didn't cut back, they just pursued the idea of even faster clear road. That's the addiction to being able to do 60 miles an hour in the middle of the storm without snow tires, chains, or anything.
But Maryland brines multiple times, but it's still less salt.
Oh yeah, because it's only 23% salt. And
So their brine isn't much.
no, it's they brine, it's just they don't put down rock salt. They just brine, and remember, the brine, that rock salt that goes on, next time the plow comes by, it tosses all that rock salt into the ditch. And then it dissolves and goes into the groundwater. So the brining was a good idea about keeping roads clear. It had very little impact on rock salt use because they just decided, we'll brine before the storm and we'll salt like crazy during the storm.
That's something local municipalities could do then.
They could, absolutely. They could calibrate their trucks and not over apply. There's all sorts of stuff. It's gonna take leadership. One of the biggest problems why Maryland is ahead of us, they have a reg that says salt is a problem in impaired waterways. They have that identified as a problem. Pennsylvania doesn't have that, they're working on it. They put in the salt criteria, EPA turned it down because they didn't think it was protected enough. They weren't the only one, other states got turned down. I don't know if anybody outside of doing what Ohio did or Maryland has done, I haven't seen a new reg unless you adopted the old EPA regs. But the data showed that the old EPA regs, they're sensitive mayflies, we did the work here, they're sensitive mussels. They can't handle the salt load that the old reg would have allowed. So there is absolutely things, you go online, you can see the guy from Maryland talk. You can go online, see the guy from Lake George, the Adirondacks have been all over this because Lake George is their money. It's their livelihood. They quantified their reduction in road salt use. Now people are talking about we use less road salt, but I think it's primarily because we've had these mild winters. And I don't blame the state. State has the best equipment. They have radar feeding into their truck, they have heat sensors buried in the road, they have heat sensors on the truck. They got weather forecasts feeding them that does a calculation and says, put down this much salt. What do you see in your township? Pickup truck with a plastic sprayer on the back. It's not a PennDOT problem. This is local. What do you see in the parking lot at the local grocery store? It's a pickup truck with a plastic spreader on the back. I had eyes open talking to some of those guys. Their challenge is they're a one-man show or a two-man show. They don't have enough time to come back every hour or two and plow. So when they salt like crazy because it could be hours before they can get back and they need the salt to do its work for them. And that's why private applicators are a huge chunk of the equation. Because, and you've seen it, parking lots are quite often the saltiest landscape around. New Hampshire has a great answer to all of that though. New Hampshire created a limited liability insurance program that protects the property owner and the landscaper who's applying the road salt. Do the training, follow the rules, document what you did. And if someone has a slip and fall or whatever, you did what was required and there's a risk. Same as going skiing, same as going horseback riding. It's the same basic limited liability coverage. And we need to revisit that for PA because I think that's the only way we can help the private applicators and the private landowners. They are so afraid of lawsuits. And there's no getting around that. If someone doesn't help them, they can't afford to not take it. But you want to know how well it can be done? Go to Longwood in the winter. They're not perfect, but man, they do a terrific job. And it's because they took the training, then they're really smart guys there. They revised it to work best for them. Because remember, salt is the enemy of the gardens. You can walk around Longwood January or February safely because they do it right. It's not saltless, but they rely a lot on mechanical removal and they have little briners. they brine before the storm's long, and if you go there during, just before freezing rain or a snow event, they're brining all the pathways. That's the coolest thing I ever saw, like, man, every development needs one of those. Cause and they also do these rotating broom sweepers, they're really good too, so snow blowers, then sweep it.
Along those lines, John, we had a couple questions online about alternatives to road salt, things like beet juice or other things. Do you have anything you can say about that? I mean, you talked a little bit about brine and then some of these other techniques like Longwood Gardens uses, but can you talk about some of those?
So it's a question about alternatives, and they're really, from my perspective, physical removal is the alternative. That's what we use forever. Every other thing we use, we're still gonna have to use dump truck loads of it. And can you think of anything that you can lay on the landscape by the dump truck load? Whether it was sand or some other chemical, that's not gonna be a problem. That's why in 1970, those really smart National Academy guys who saw the piles and saw the trucks said, we're gonna have a water pollution problem. At a time when we didn't have a national water pollution law 2 years before the Clean Water Act, their eyeballs told them the truth. You can't do that. So I think we'll rely more on mechanical removal. And we're gonna have to change our expectations. It's either that or you're gonna be having to deal with your drinking water impaired. You're gonna have to be dealing with your infrastructure falling apart. It's a whole science of looking at how road salt erodes iron and concrete, bridges, roadways, sidewalks. It's just a thing now. In the spray zone next to a road. You know, how the roads, the cars go by and creates a mist in the spray all the way up to here. So that's what I think is really our answer. Is mechanical removal and brining. Yes.
You have a pamphlet or something to really communicate with the municipalities on best practices. You have something that they can physically discuss in their.
I have, we need to do more. Their problem is, and this is just my experience, is where do they start? And what's their liability? It's a tricky business across the board. It's a problem that 2 generations ago, no one thought about in the way that modern decision makers do. But it will change, just like it's changed in other communities. It's just, we're still struggling. So Dave and I gave a presentation, 7 municipalities, talked to them, they were all in, they totally understood it, and then the comment came, oh man. Just one more thing for me to worry about. You know, that they're feeling a bit overwhelmed. Should they be worrying about PFAS? Should they be worried about pesticides? Should they be worried about road salt? Yeah. For all 3. That's what's happening in their neighborhoods. That's one of the things that I think we've done over the last 55 years for the Clean Water Act, or 53 years. We've deferred to the regulations, and we've deferred to the regulators. The Clean Water Act came around because people like you said, we need this help. Because there was no question, they didn't need data. They could see the pollution, they could smell the pollution, they could feel the pollution. Everybody, we didn't have the data. It didn't require data. Dead fish were right in front of your eyes. Now our pollutants, you can't see them, you can't smell them. But that's a great thing. We can measure this. Can't see it, can't smell it, can't feel it. But you guys with little or no training can go out and measure it. And that's a new way of engaging the public, because if the public doesn't start asking, how are the politicians and the decision makers ever going to step up and do something? They're just responding to pressure. And we stepped back decades ago and said, well, the regulations will protect us, or the regulators will protect us. But now the general public doesn't know they have a PFAS problem. They can't measure it, they can't see it, they can't smell it. They don't know they have a pesticide problem. They can't see it, they can't smell it, But road salt is a great engagement tool to get this conversation started because we can measure. They see it happening in a big way. And they ask for it, they're paying for it every year. So there's a money thing going on too. It's gonna be a complete discussion, but I think it's maybe an entry point for changing how water pollution, because it's not our only pollutant. It's just one, I can talk to you guys and you can help me measure.
Expensive.
So you have the graph to go up in the 1960s, and I recall as a kid. In the fall, my dad would put snow tires on the car and he'd get chains in the car, and that's what people did. And when it seems front wheel drive cars where you have the weight over the drive wheels and all season radial tires, which are much better, they're not the same as snow tires. Without snow tires and those, you have to have clearer roads, or people are not gonna be getting anywhere. So just the driving.
Changing our
Driving,
So
it drives a need for clearer roads.
yes, there is, that expectation is gonna be hard to change. But when you start tasting your drinking water and it's salted, or you have to pay just like you do if you're in a drinking water area that you have a PFAS problem. If you have to put your drinking water on a reverse osmosis, that's gonna cost a lot. Excuse me. So you're right, there are old fashioned ways of going back. We got rid of snow tires for the best of intentions. Just nobody paid attention. We heard this quote just last week. Road salt's not a problem, it goes away. I was floored.
John, can you
Go ahead.
grab a drink of water? And then we did have some questions online talking about that, about the potability of water and drinking water intakes. And I know you have spent time thinking about that and studying that, at least in this area. Can you talk a little bit about that?
Learn how to talk about it responsibly, so I'm not sure how to talk about it. But it is a problem. It will be more of a problem if we don't change our way. So another tool in our toolbox for the conversation. There are places that have drinking water problems already. Matter of degree and a matter of your concern. Probably true in bottled water as well as public water, because a lot of bottled water comes straight out of the street. Yes,
About it, anything else?
I'm losing my voice.
Yeah, I replied to a comment online that we would ask you questions until you lost your voice. I thought I was kidding.
Right,
I was just gonna mention that, through the PA Road Salt Action Group, there is a group, interested in, working on a criteria for Pennsylvania. So
Yeah.
there's a group you can join there, that is, there's a petitioning process. And they have a group working on that, so if somebody's interested in that, you can join that effort.
if nothing else, you can learn more, they're a good inventory. I do the science and I'm perfectly willing to do the communication and teaching about what science says. But I don't wade into the deep end of policy decision making. That's my wader's not that deep. In the back.
Last year, when you did cut the salt, you sent out these cards. What are you gonna do this year? You gonna do a similar program, or are you? Now you wanna expand on what happened last year?
We'll do both. We did send out cards, those were generally to individuals, but what we try to do on any of these kinds of things is connect people to other people, so they're not flying solo. So we send out, some of our biggest shipments were 50 to 100 strips to groups that were working all over Chester and Delaware County or wherever. We will be doing our best to respond in both ways. There will be a mailer, but there will also be just a general ask. If you're working with a group and you think you're gonna hit 100 sites, then let's get you 100 strips. If you're working with a smaller group as an individual and you're gonna hit 10 sites, then we'll get you 10 strips. The thing with the larger group, we never have enough connectivity meters. So if we get a conductivity meter that can be shared, then we have a back check. And that, from my perspective, makes our data, when presented by whomever, we have two confirmations of what salt concentration is. And when you're dealing with, just volunteers, having evidence that that you confirmed your measurement was reasonable, then the real question is, what are we gonna do? Not how good are your data? So the messenger doesn't get the focus on them, but rather the message. I found a lot of salt. What can we do? Anything else? Mark.
I'm Jennifer Latsko and I'm Pennsylvania Road Salt Action. So thank you for talking about that today.
You came all the way down from the Lehigh.
Yeah. So, anyway, I also have the QR codes here for anybody here that you want to scan to get more information or participate in our working group. We're right now working on resources that people can use, things like slide decks, social media postings. We have a letter to the editor that we've written that if anybody would like to use that now with their data to follow up and send a letter into the editor, it's all written for you. You just basically put in your name of your organization and some information about your data. And I'll share that with Dave. Maybe he can send that out to people. But we're in the process of creating a website where this will all be in one central place. We do have the group working on the regulation. We're also working on the Green Snow type program, similar to what's going on in New Hampshire. That's one of the long-term goals. So.
And Valley Forge TU explored that a few years ago. I don't know what came of that. Valley Forge Trout Unlimited.
Yeah, I mean, we had a presentation by folks in New Hampshire, but it didn't really go anywhere.
Don't let these guys stay on the sideline. Their ability to get people's attention is far exceeds mine. We will be working on our data still. By the time you see us in January, we'll have a better grasp. The other thing is, and this is for anyone online still or anybody here, we will be looking for you to ask us how you want to talk. If you handed us 10 data sets or 10 samples, 10 sites, who do you want to talk to and how do you want to talk to them? Because that's the next step. With 1,000 sites, nobody wants to show the data set the way I do. I've got it sorted out by hydrologic units, so I can put together sets of data that are in the same area, that are flowing to the same water. I have them sorted by county. I can give you a county number. There's any number of ways we can do this, but what I really want you to do is think about how you want to talk about it, because I know how I do it, but you have to own it when somebody's talking, and that means being comfortable with how you're messaging it. And then I learn from you, and I'll steal it. So